Hello everyone. In this video, we are going to discuss with the question minimum window substring. And yeah, this is a very good question of a sliding window. Let's go to the question. We are given two strings S and T, which are of length M and N respectively. We need to return the minimum window substring of S such that every character in T, including the duplicates, is included in the window. And if there is no such substring, we need to return the empty string. Okay. So, see, what's the question says? The question says that we have a string S. Let's suppose this is a string S. In this string S, we we need to find a minimum window substring such that this substring contains all the characters of the string T. This substring contains all the characters of string T, and we need to output the minimum substring, that is minimum length substring. We are told a minimum window, so that is minimum length substring. Okay. So just tell me, there are two things. First of all, we need to identify that this is a question of sliding window. The second is that we need to identify that whether it is a fixed size sliding window or a variable size sliding window, isn't it? So yeah, let's suppose you have in this question we are given that we need to find a minimum window substring. We are told about substring. We are given the words window also. So yeah, this pretty much is very much the indication that okay, this is a question of fixed. This is not a question of like any other thing other than sliding window. So yeah, sliding window can be one of the approach. Why? Because we are given substring. First of all, we are given substring. We need to do operation something like substring. And the second is that we are already given that we need to find a minimum length substring. We are given that minimum window batao. Ye de diya. So they have automatically used the word, isn't it? So yeah, this is the question of sliding window. Now the next thing which comes in mind is this a fixed size sliding window or a variable size sliding window? See, we are told that in the window, it should contain all characters of T. All characters of T. But they have not told that the window should contain only the characters of T. It can contain other letters also. For example, let's suppose T is AABC. Then AADBC is a valid window. Though D is not in the string T, but then also AADBC is a valid window because they have not told that only the characters of T are allowed in the window. Even the characters other than T are also allowed. So can we say that this is a question of variable size sliding window because we don't know the size of window, isn't it? Size of window ही तो बताने बोला है ना. Minimum length substring we are told to determine. So yeah, it's a question of variable size sliding window. So now let's see how we can approach the question. See, we have string T, isn't it? What we can do is, first of all, we need to know which characters come how many times in this string T, isn't it? So what we can do is, we can store a map. We can use a map to store the frequencies of characters coming in string T. And at the end, we can keep a count variable, which will tell us that what is the size, like what is the size of how many characters are coming. For example, if string T is AABC, then M of A, character A will be 2, M of character B will be 1, M of character C will be 1, and the value of count will be 3. Count stores that how many keys we have in our map. It is determined by the size of map. Like if we use something like mp.size, we can get this, that how many keys are present in the map, isn't it? So yeah, we can just use maps to store the frequency. Now, once we got the frequency of which letters are coming, like which characters are coming, how many times, what we can do is we can traverse over the like J, all the string. For example, we have string S. This is string S. Initially, we have our I over here and we have our J over here, isn't it? This is how we approach the sliding window question. Now, every time we go over this, what we can do is we can just see that the character we are encountering has ever come in this a string T or not. If we have some character A, we will see that this character has come in string T or not. If it has come in string T, we will decrease its frequency. For example, over here m of A is 2. Now if it has come in string T, what we will do is we will decrease its frequency to 1. Now let's suppose we get B. What we will do is we will decrease its frequency by 1. It becomes 0. But once it becomes 0, we have got that, okay, so we got that the count of these, like we don't want any more B's, isn't it? So what we can do is we can reduce the value of our count from 3 to 2. एक बार हम लोगों को B का, we want total 1 B's, isn't it? So when we got the number of B's we required, we can reduce our number of count, isn't it? Count tells us that how many characters we need more, how many unique characters we need more. But once one of the characters need is satisfied, we can reduce our count. Similarly, let's suppose we encounter A again. What we can do is we can reduce the frequency of A to 0. Let's suppose we get D. But here we know that we don't have D in our map, so we will do nothing with our map. Okay. Now let's suppose we get C. Now what we can do is we can reduce our C to 0. Now once A became 0, we reduced our count from 2 to 1, and once C became 0, we reduced our count from 1 to 0. Now once we get the value of count as 0, what does this mean? This means that from window from I to J, we have all the characters of string T, isn't it? We have all the characters. Okay. So once we have all the characters, so yeah, this is a possible window. But just tell me, is this the minimum size possible window, or like more minimum we can do? For example, let's suppose you have got window something like your I was over here, and you got D, A, B, A, D, C like this. Like this is a string S, and your J is over here. And your string T is nothing but A, B, C. Let's suppose this is your string T. Now, if you see that this is a valid window, like over here, you will get your value of count as 0. But just tell me that if we, instead of taking this D, if we shift our I over here and take this window, this is also a correct window, isn't it? Like we are getting A 2 times in this, we are getting B 1 time and C 1 time. So this is a valid window. And also this is of length less than this window, isn't it? So this is the more precise window. This is the window which will give us the answer. So what we can do is whenever we get our value of count as 0, what we can do is we will shift our count, we will shift our I. Like this is a valid window. We can store. Okay. So this is a possible answer. So we can store this answer somewhere. We need to return the string, the minimum possible string. So what we can do is we can store the starting index and ending index of the string. Okay. Like यहाँ से शुरू हो रहा था, यहाँ end हो रहा था, ये वाला string. We can store this, and we can even store the length. Length is j minus I plus 1. Okay. So what we can do is we can shift our I till the value of count is 0. Because jab tak value of count 0 rahega, like over here also the value of count was 0. But once we shift our I from D to A and removed the contribution of D, even then the value of count is 0, isn't it? Yahan bhi value of count 0 hi hai. But this is a more precise string. Like this is the string which we require. So, okay. So that is one of the, then again we will get a length less than the length we got over there. So we will store our one of the possible string as this. Okay. Now let's suppose we shift our string index I from A to B. Once we do this, what we will do, we will increase the frequency of A. Now once we increase the frequency of A, we will get the frequency of A as 1. What does this mean? This means that the string has like this character has come in this is required. This character is required in some window and we have not got it because क्या था कि हमारा टी में जो भी कैरेक्टर्स आया था उसका फ्रीक्वेंसी हम लोग मैप में स्टोर किए थे ना. फॉर एग्जांपल एमपी ऑफ ए हम लोग 3 स्टोर किए थे. Now when MP of A becomes 0, this implies that okay, the need of A is no more. But once MP of A becomes 1, what does this mean? That we need one A to for all the characters of T to come in this window, isn't it? We need one A. Because once we get one more A, what we will do is we will do 1 minus 1 which is equals to 0, which will imply okay, we have no need of more A. So once we get our frequency of A as 1, so what we will do is we will increase our value of count, because this means that we need one more unique character in this. एक बार फिर समझते हैं चलो. Like let's try run this example. DABADC. DABADC. And let's suppose your string T is AABC. Okay. So what you will do in your like initially your I is over here and your J is over here. And what all are initially stored in your map? In your map you has M of A as 2, M of B as 1, and M of C as 1. Okay. Now you come to first of all this D character. You will check that this D character is present in your map or not. If it is not present, you will do nothing with it and just you will shift your J over here. Once you shift your J over here, you will see like, and initially you have count as 3. Okay, just keep it in mind. You have 3 keys. Okay, you shift your J over here. If you shift your J, you encounter A. You will check that A is present in this map. Yeah, it is present. So what you will do is you will reduce its frequency from 2 to 1 and shift your J. Now, since it became 1 and not 0, so we will not reduce our count. We need more A, isn't it? Now we came to B. Once we came to B, we will check that if this character is present in our map or not. It is present, so we will reduce its frequency from 1 to 0. But since its frequency becomes 0, this means that the count of one of the unique characters decreased. We don't need any more B, isn't it? So what we will do is we will reduce count from 3 to 2. Okay. Now what we will do? We will shift our J. We came to A. Once we came to A, we will see that if A is present in this map or not. Yeah, it is present. So we will reduce this frequency from 1 to 0. And since it becomes 0, so we know that we don't need any more A. So we will reduce its count from 2 to 1. Okay. Now we shift our J over here. We encounter D. And since we encountered D, we have no D in our map. We will do nothing and simply shift our J. Once we shift our J to C, so we will reduce the frequency of C from 1 to 0 since C is present in our map. And since it became 0, so we will reduce our count from 1 to 0. Now, once the count becomes 0, this implies that all the characters of string T is present in this particular window from I to J. So this is a valid window. So what we can do is in starting, we can store like starting value of the string of the possible answer. Initially, we can keep it as -1. We can keep an ending value, which is initially -1. And we can store the minimum length. Let's suppose minimum length we denote by mn as int max. Any value we can take like largest possible value int max. So now we will check that if the window length we got over here is less than the window length possible before. If this is the case, then what we can do is we can say that, okay, so this is the shorter window length. So we can store its value and we can shift our start to I. Like we need to return the string. For that, we need to know the starting and ending point of string, isn't it? So that is why I'm storing this start and end. And our ending value to j. Once we do this, are we done with it or we need to do anything more? Should we shift our j from here or should we do something else? Yeah, you guessed it right. We should do something else because see, this is a valid window. I agree with you that this is a valid window. But can you all see that this is also a valid window? This is also a valid window, isn't it? So what we can do is we can shift our I till the value of count is 0. So we will just simply run a loop that while count is equals 0. What we can do is we can shift our I. Before shifting our I, we know that once we just enter this loop, the value of count is 0, isn't it? So we can just keep this condition in that once we enter our loop, this is the valid condition. Okay. Now we can check that we need to remove the contribution of this ith number, isn't it? But just to tell me that this t contributed anything or not? It has not contributed anything, so we will not remove anything. We will just simply shift our I. But once we shift our I comes over here. So now the window from I to j has a length shorter than the previous window. So what we will do? We will update these values. We will update mn, we will update start, we will update end. Okay. Now we came to A. Because while coming to A, the value of count is 0. Now we removed the contribution of A. How we can do that? We can increase that m of A plus plus. When we are removing the contribution of a character, when it has come in the map. Like D hasn't come in this map, so we know that it hasn't contributed anything, so we are doing nothing with it. But we know that A has come in the map, isn't it? So we need to remove its contribution, and for removing its contribution, we need to increase its frequency. What does this increased frequency like shows? This shows that we need 1A, isn't it? Now, once this frequency becomes 1, this means that we need to increase our value of count, isn't it? So, okay, we will increase our count to from 0 to +1. And once we increase our count, we will come out of this while. And at the end, we can check that if the value of start is not equals to -1, this means that we got a valid answer. So we can print a string from start to end. Like we can return this string. Otherwise, we need to return an empty string. So yeah, this is the approach. I hope you all got it. Let's code it down. Let's take the value of s in n and value of size of t in m. So what we can do is we can store a map of character comma int, which will count the frequency of all the characters, and we can traverse over the string t, auto character in string t. What we can do is we can just increase this frequency. Okay, now in count variable, what we can store the size of this map, like what are the number of keys. Now we can initialize our like something, like we can initialize our start of the output string as -1 and end as -1, and initial maximum length possible as let's suppose int max. Okay, now for sliding window we will initialize our I to 0 and j to 0. Now we will traverse over this like string s, and what is the maximum value j can go to? It can go up to n. Now, first of all, tell me, like every time we need to note down the contribution of the jth character, or only we need to note down if that character is present in this map. We will only note down the contribution of the jth character if that character is present in the map, isn't it? So yeah, what we will do, we will check that if the jth character is present in that map. How we can check that? We will check that if mp.find s of j is not equals to mp.n. If this is the case, this means that jth character is present in the map. So what we can do is we will reduce this frequency. And after reducing the frequency, we will check that whether its frequency became 0 or not. If its frequency became 0, we will reduce our count. That is the number of unique characters we need. Okay. Once we are done with it, we will check that if the value of count is 0. If this is the case, this means that we have a window that contains all the characters of string t, isn't it? So yeah, we will run a while loop till the value of count is 0. Once we get the value of count is 0, this means that we have a valid string. We have a valid window which contains all the characters of t. So we can just put our condition over here that if j minus I plus 1, if the size of this window is less than the size of the window we got till now, because initially we have not got any window, so initial size is int max. But if we got a window which has a size less than the original window we had, so what we can do is we can just take the minimum of that. So yeah, mn equals to j minus I plus 1, and now the start becomes I and the end becomes j. But we need what we encountered over here is, like even if we got a valid window, it may be that the size of a valid window is even less, like we shifted our I over here. So yeah, we need to do that operation. We need to check. Now we need to remove the contribution of ith character, but we will not remove the contribution of ith character always. We will only remove if it was present on the map, isn't it? So what we will do is we will check that if in the map that ith character was present, because जब characters present था तभी हमने उसका contribution note down किया था. So if the character was not present, so we have not noted down the contribution, isn't it? So why we will remove the contribution if we have not noted it down? So we will check that whether we noted down its contribution or not. So how we can check that? If that ith character was present in the map, so definitely we noted down its contribution. And if that ith character is not present in that map, so yeah, we are pretty sure that we have done nothing with that. So if mp dot find s of I is not equals to mp dot end, if this is the case, this means, yeah, we noted down the contribution of ith character. So we will do mp of s of I plus plus. And in this case, we will check that if mp of s of I is equals 1. If this is the case, this means we need to increase the value of count to plus plus. Okay. And if this is not so, we will simply shift our I. And in this case also, we need to shift our I, isn't it? Okay. So so now we know that, okay, this work is clear. So we will simply shift our J. Okay. So I hope it runs well. Now coming out of the loop of J less than N, we will just initialize our output string to, let's suppose, empty string. Now we will check that if the value of start is not equals to -1. If this is the case, that means we got a string, isn't it? That contains all the characters of string t. So what we can do, we can just run a loop from start till end, and we can do output string as plus equals s of I. So once we are done with it, we will return our output string. So in this case, if the value of start was -1, we will return an empty string. And if the value of start was not equals to -1, so in that case, we got a string, isn't it? So yeah, let's try to run it once. I hope I don't get any compilation error. Okay, it ran. Let's try to submit it. It's working well, isn't it? What's the time complexity of this code? If we just check, what we are doing is I एक ही बार 0 से n तक जा रहा है and j is running till n. So yeah, the time complexity is nothing but big O of n in this case. And if you look like you are traversing over this map, so it's big O of m. So big O of m plus big O of n. So that's the required time complexity. So I hope you all got this question pretty much clear. Thank you and keep watching.